And so now I'd like to talk about what I've been focusing my efforts on, what I've really been spending time, in addition to scientific research, also in my CSP doing, and it's researching the Stirling engine. So I'll just take a few seconds to explain what the Stirling engine is. As you can observe, it's a heat engine, and all it works on is the compression and expansion of heated air. So as you can see in the diagram there, you have a heat source hitting the air compartment right there, and the air inside expands, and it pushes the piston out. So when you have your piston moving out, your flywheel rotates. Now that rotation is what creates mechanical energy, and it pushes the piston back in. There'll be cool air that's coming, you have the contraction again, expansion, contraction. So it's a continuous cycle. Now, what you can do with the flywheel, the mechanical energy, is that you can convert it to another form of energy. So the device is called transducers. They convert one form of energy to another. And in this case, you can convert mechanical to chemical energy. So you save your energy to use it up later. Or you can convert it to electric. So you can power your radio or your light switches. Now, the interesting thing about these things, the Stirling engines, is that you can place them at the center of the solar panel that we had in this case. So instead of having your gali or chapati or whatever you have at the center, you place a Stirling engine. So the heat from the sun is being centered on your Stirling engine. So it's technically a free source of energy, a free source of power. And so in normal day, is the Stirling engine really that effective? What can it really offer? Is it better than the photovoltaics that we saw earlier on my grandparents' roof? Because photovoltaics are the most popular device, the most popular technology out there for solar harvesting. And research actually shows that the Stirling engine is cheaper, it's smaller, and it's much more effective. So I just put up a few of the comparisons. With the Stirling engine, you have it operating on the sun's heat as opposed to the light. So with the sun's heat, you can run your Stirling engine. Photovoltaics have to operate on sunlight. So when you have maybe cloud cover or minimized sunlight, you can't use your photovoltaic, but your Stirling engine still runs. And I'm sure you've been reading, the Stirling engine has a higher conversion percentage, 30 to 40%. With a photovoltaic, only 18% has been the highest percentage that they've had commercially. You have the Stirling engine being made from locally available materials. And in this case, I'll be able to show you later how my group, my team, Green was able to build a very small Stirling engine from available materials on campus. With the photovoltaic, you have to have some expensive materials like silica, and to get to that 18%, it's taken millions of dollars of investment. And the heat storage is more efficient than electricity storage. So those are just some of the comparisons. And so is this Stirling engine being used anywhere else? Is it a new idea? It's really not. The idea of the Stirling engine came about in the 19th century, and very big companies, and NASA itself is actually investing in the Stirling engine. And so I'll just read you a quote from the director of the Solar System Exploration Program at NASA. The Stirling engine is actually something we've been investing in for almost the past 3 decades at some level. And it's now reached the point where we're ready to make the next step forward. So satellites in space actually use things called RTGs, which are solar thermal collectors. And they use the sun's heat and light to operate them so that they can move around the Earth, so that they can orbit the Earth. Now, with the Stirling engine, it said that it will be half the weight of the RTG, and it will be 4 times more efficient, and it will be cheaper to build. And we'll also use less fuel to get it up into space. So NASA is actually embarking on a program to replace the RTGs that are in space with Stirling engines. And it's not only in space, there are various companies right here that have been investing in Stirling engines. And so it caused me to think, sorry, went a bit ahead of myself. Is the Stirling possible in Africa? Is it because as I showed before, we have the map of Africa with all those red points, all those dark points. So can we harness the energy that we have in Africa? Is the Stirling a viable solution? So far, it's shown promising results, but I really can say it's a question that I have to carry forward with me. But I also push it forward to you to think about it. So in whatever field you're going into, can this really old technology change the way we operate in Africa? Thank you very much for your time. So I'll take it. All right.
So you spoke a lot about the advantages of the Stirling engine over photovoltaic cells, and I was thinking I would like you to address two things. First, the compatibility, the compatibility of the Stirling engine. I mean, because you can use the photovoltaic cells in your home without having to dedicate a huge space in your house to an engine. And also, what happens if you're in country like South Africa, like during winter, when there's low heat? So, yeah.
Okay, so to address the first question, it's actually possible to keep the Stirling engine in your home. There's a company that's been investing in it. If you look at a name Bill Cross on the internet, he gave a TED talk a few years ago, and they developed Stirling engines that were customized for the home, and it was just petals like what we saw in Zanzibar, but a much smaller version with an engine at the center, and you can place that on your roof, and it actually has microprocessors that sense where the maximum heat from the sun is coming in, and you have maximum harnessing of energy. And with your second question on the low heat or low solar insolation, in that case, you can't use the photovoltaic as well. So the Stirling engine really wouldn't be a primary source of electricity, to be a supplementary. So in terms of winter, then you'd have to resort to other forms of electricity. And in the time that you'd be using the engine, you'd be able to save enough money to buy something for that time. I'll just take one more question. Spencer.
Could you design a Stirling engine to be able to run on the heat of the sun, and that same model to be able to run on some sort of external combustion, say of hydrogen or something like that?
That could be investigated. I don't see why not, because you could have separate chambers for the expansion and contraction of the air, but it would really depend on what you want to use it for. And I think in that case, you will be able to address OI's second question on using it during winter and so on. So thank you very much.